Hello everyone, I'm Lee. In this video, we are going to look at inheritance in C++. So we are going to use the same sample project for inheritance in Java, the shape one. So let's first look at the shape class, the shape.h header file. In this class, we can see has a relationship. So in shape class, again, we want to model the position. So we use a position class. Here we use a pointer to a position object to keep track of the position. And we have the access function for xy coordinate and the mutator function for xy coordinate. And we have the print function just to print out the current status, and the get area one. So you see, we see something new here. The constant ones are not new things. They just mean get x, get y won't modify the state of the object. The similar thing here, print function won't modify the state, and constant here, get area won't modify the state. So the difference we can see here is the virtue in front of the D structure. I will briefly talk about here about what that virtue means here, but we will come back to this later. So virtue here enables the children's D structure get invoked. And the virtue here enables dynamic bounding for print function. Virtue here enable dynamic bounding for get area. So virtue doesn't mean abstract. They just enable dynamic bounding. And get area here, you see, this is an abstract function. We know that because we put a assigned to 0. That means we don't want to implement it here because we don't have enough information. So when you have this abstract function, like this abstract function here, that makes shape class abstract, but it just doesn't have the abstract keyword. But when you have a function that doesn't have implementation, that makes the class abstract. All right, so let's focus on the composition pattern here. The has a relationship. So take a look at the position class. The position class is just like before. We model the xy coordinate and we provide a print function here, and the implementation is trivial. So get x, set x, get y, set y, and the print function. Now let's take a look at the shape class implementation. In the shape class, we purposely display some message here. Just to show us the constructor get invoked, the D structure get invoked. So for the constructor, we need to initialize the position pointer, and by creating a new position with the passed in x and y coordinate. The D structure, we need to delete that object. And for get x, get y, set x, set y, we just delegate the task to the position, to the object pointed to by position. So that's the syntax about that. So in this video, we just focus on one relationship, the has a relationship. In our case, this has a, we don't put an object there, we put a pointer to the object there, which means you need to allocate the memory in the constructor and deallocate the memory in the D structure, and whatever things about position, we delegated to this position object to do that. Thank you.